Hi guys, welcome back to my YouTube channel. So today I'm going to explain to you how you should answer quiz 4 for chemical equilibrium and ionic equilibrium quiz question. So altogether we have 3 different questions, and let's get started with the first one. Question number 1. Hydrogen gas and bromine gas shall react to form hydrogen bromine with equilibrium constant equivalent to 62.5. Infer the equilibrium concentration of bromine if the concentration of the HBr is equivalent to 0.35 molar and the concentration of hydrogen is 0.22 molar at equilibrium. This is a rather straightforward question, so how you're going to tackle this question is that you need to write the chemical equation, which is actually given to you in the question. So H2 plus Br2 will produce 2HBr, right? So this one, make sure that you write the balance equation, because in the question you just given hydrogen gas plus bromine gas will produce the hydrogen bromine, right? So you know that H2 plus Br2 will produce HBr, but you need to make sure that you need to balance this equation out. If not, your Kc will not be correct. So from here you need to calculate the Kc. So the Kc is whatever in the product, which is the HBr, but since the HBr you have 2 here, so to the power of 2 divided by H2 and Br2. Alright, and then when you read back the question, you were asked to infer the equilibrium concentration of Br2, but the given to you the concentration of the HBr and also the H2 is such, so and then the value of Kc is given to you as well. So the Kc is 62.5 and the HBr is 0.35 square, H2 is 0.22, and the concentration of Br is the one that you want to calculate, right? So what you can do here is that you need to bring this up. So we are going to bring this up here. So this one is 62.5 times 0.22 Br2 is equivalent to this one, 0.1225. So from here, just need to times this one, you shall get 13.75. Br2 is equivalent to 0.1225. Therefore, the Br2 is equivalent to 0.1225 divided by 13.75. So you should get the concentration of the Br2 is equivalent to 8.9091 times 10 to the power of negative 3. Question number 2. The reaction between 0.5 molar hydrogen gas and 0.5 molar iodine will produce a product Z. The concentration of the product Z at equilibrium is 1.5 times 10 to the power of negative 4. Determine the Kc for this reaction. For this question, you were asked to predict what is the product Z. So given to you is a H2 plus I2, so definitely you will produce Hi, but you need to make a balance equation, so you have 2 around here. So the next up, you need to write the ice diagram. So from the ice diagram, so you need to look at the question, the reaction between 0.5 and 0.5. So both are the same. So we have here 0.5, here is 0.5, and initially there's no product being formed. So at change, you shall get negative x, and here must be positive 2x. Why 2x? Because we have 2 around here. Right, next up is do the summation, which is 0.5 minus x, 0.5 minus x, and this one will be 2x, right? So Now you can easily calculate the value of Kc. So the value of Kc is equivalent to whatever in the product, 2x. Since you have 2 here, so you need to have to the power of 2. And then 0.5 minus x, 0.5 minus x. So what are other information given to you in the question? See, it says here that the concentration of the product Z at equilibrium is this much. So the concentration of product Z, which is 2x, is equivalent to 1.5 times 10 to the power of negative 4, right? So since you know that this is 2x equivalent to 1.5 times 10 to the power of negative 4, therefore you can find x is equivalent to 1.5 times 10 to the power of negative 4 divided by 2. So you get your value of x is equivalent to 7.5 times 10 to the power of negative 5. Right. So from here, you already know what is the value of x. So you just need to plug in all these x's with this value so that you can get the value of Kc. So since we already know what is the value of x here, so we need to put all this value of x inside the x's in the Kc. So the Kc is equivalent to 2x. So x is 7.5 times 10 to the power of negative 5 square divided by 0.5 minus 7.5 times 10 to the power of negative 5 square. So because this is the same, so your Kc shall be equivalent to 2.25 times 10 to the power of negative 8 divided by 0.2499. Hence, you will get your Kc equivalent to 9.0027 times 10 to the power of negative 8. So this is the final answer for this question. Let's move on to the final question. Question number 3. The concentration of the H plus of a 0.02 molar solution of weak acid is 1.9953 times 10 to the power of negative 4. Estimate the Ka for this acid. Alright. So how are you going to answer this question? Because you were not given the exact acid, so it's just a weak acid given to you. So you can say that Ha, so H is for acid, and then it's a reversible equation. So alright, so and then you need to make the ice diagram. Same drill, initial change and equilibrium. So the initial concentration of this solution is given in the question, which is 0.02. So 0.02. At first there will be no product, so 0, 0. And then at change shall be negative x, positive x, positive x. And then at equilibrium is the summation of the initial and the change. So 0.02 minus x, x and x. So from here you can get the value of Ka, which is equivalent to x times x divided by 0.02 minus x, which is the product minus the reactant. Okay, happen to be in the question says here that the weak acid, the concentration of the H plus is equivalent to 1.99353 times 10 to the power of negative 4. So it means that this concentration of H plus is actually equivalent to x. So x is equivalent to 1.9953 times 10 to the power of negative 4. So what you need to do is that you need to plug in all these x's with this value. So you get your Ka is equivalent to 1.9953 times 10 to the power of negative 4 square divided by 0.02 minus 1.9953 times 10 to the power of negative 4. Right. So from here you should get the value of Ka should be equivalent to 2.0107 times 10 to the power of negative 6. So this is the final answer for this question. Alright, so this is the end of our discussion for quiz chapter 4. So I hope you can understand this chapter well. So I see you again next week for our final chapter, chapter 5. So see you again, and thank you very much.